Hello, welcome back to the channel. Today's video we're going to keep talking about quadratic functions, quadratic equations, and parabolas. Now just kind of a word of wisdom here. We are technically entering the second half of the chapter. We have 3 lessons left in this chapter. This one is, if I'm just being straight up honest with everybody, one of the harder ones, at least for me as a teacher. This is something that I have never really used a lot. In fact, I don't even remember if I taught this very much in some of our previous books. But I did check on our standards, what we are supposed to know, what is expected of us in Algebra 1 in the state of Missouri. And so this is a topic that we are expected to know, so I will go over it. Now, in full disclosure, our textbook goes into a lot more detail. They kind of extend some topics that we really don't need in Missouri. And so I'm just going to kind of hit on the highlights. So like if you actually have your textbook with you, you'll notice that there's some parts of the lesson that I'm going to skip and some questions in your book that I won't put up on the website today. So I'm just trying to hit the basics because, to be honest, that's all we really need to know. And our book goes into a little more detail than we really need, at least for Missouri. So anyway, what we're looking at today is still similar, but it's just twisted a little bit, right? I kind of made this little chart right here, this T-chart, of what our questions used to look like at the beginning of the chapter, right? So far in all of my videos, we've been doing equations that look like this, right? Where we had ax squared plus bx plus c. And I just made a couple of examples here so you could hopefully recognize this is what they used to look like. And then over here on this side, on the right, this is the format that they're going to look like today. And so you can see there's a slight difference, right? Over here, we had ax squared plus bx plus c. These look like the factoring questions that we did with polynomials last chapter. Now, all of a sudden, there is no b, there is no c. Kind of the letter c and the letter k are almost acting like the same thing. But there is no b. And you notice now all of a sudden we have a parentheses and something squared. And so over here, we've never seen a parentheses before. And now we do. The x is involved in a parentheses that's being raised to the second power. And so that's going to change some of the way that we attack these questions. This is going to make us do a few more things. It's not necessarily harder than what we did in the beginning part of the chapter. It's just a little bit different. All right? If you remember, how did we solve these questions? Well, first we looked at kind of what each letter represented, right? This letter A, remember what this did? This letter A always affects how wide or narrow the parabola is, right? When this letter A is bigger than 1, the parabola is very narrow, right? It's something like this, very, very close together. When that letter A is less than 1, when it's a fraction like 1/2 or 1/3 or 2/5, it made it much more wide open. See how much farther apart those two lines are? That's what the letter A does. The letter C was always the y-intercept, right? The letter C moves it up or down on the y-axis. When the letter A is negative, that flips it and makes it go upside down, whether it's narrow or very wide. It doesn't really make a difference. When that letter A is negative, that's going to make it upside down and open down. And so what we used is, remember we had this formula, the axis of symmetry. We did the axis of symmetry, which was this setup right there. And then we would usually take that answer and then we would plug it back in to the original problem in the spot of x to find the vertex. Okay? That's what we had to do on the questions all throughout this chapter so far. Now today, how am I going to do that? Is there any way I can use this on a question like this? And the answer is no. I mean, there is no letter b. I mean, there's no letter b up here. There's no just x to a regular power. There is no x squared. Like, how would I pick the a in this? I mean, there's an a out in front of the parentheses, but the a is not the same over here where it's the coefficient on the x squared. So since this is written a little differently, we kind of need a new game plan. Now, they're both parabolas. These over here that I drew are still going to look like these over here. They're still parabolas. They look the same, but because the format of the original problem, the format of the function is written differently, we have to have a different game plan. Just because it looks different up here, we're going to have to do something different. They're still parabolas. They're still going to open up if this is, now our letter A is still going to apply, right? This one right here is still going to be pretty wide because it's 1/3. And this one right here, because it's a number bigger than 1, is still going to be pretty close together. So that part hasn't changed. The parts at the end are going to move it up or down. All right, this is going to be up 3 places. This is going to be down 3 places. But all of this stuff in here with the parentheses is going to, well, it's going to make us do a little bit of different thinking than we had to do over here. There is no way to do axis of symmetry on this side because the letter B is now all of a sudden in the middle of all this parentheses and squared, and it just made it a lot more complicated. Okay, so there's really no work there. I just wanted to show you the difference, how you can tell when it looks like the ones that we did at the beginning of the chapter, and now all of a sudden we have parentheses, and that's the biggest giveaway, and the parentheses is to the 2nd power. Okay, so that's the difference between today and yesterday. There wasn't really anything to work out on those. Okay. Here is the basic ones. You'll notice this is very similar to my last board. Okay, so this is just a few. These are just a few examples of introducing what is going to need to be our thought process when we look at these. Right? All of a sudden, we don't have this format anymore. This is gone. Right? There is no A and B, and there is no C. Right? In fact, C on this one, I mean, it's not even there. So now we've got a parentheses. What does this tell us? Okay, so the most important thing, that's not what we're dealing with. I'm going to scribble that out. The most important thing I feel like that is new for us is this right here, this letter H. And in fact, up here it's a minus H, or subtracting H. This is going to give us a good idea about where this graph is, right? If you remember the original one, the original statement, the easiest one we could do, all right, this guy, the parent function, this one always started right at the origin, right? It always had its vertex right at the origin, and then it either went kind of wide, sometimes it was narrow, sometimes it went up, sometimes it went down. But whenever it was just like this, right, ax squared, it always had its axis of symmetry right here, and it always had its vertex on the origin. That was the basic one that we can do. Now today, on all of my examples, look, the x is not just an x. Now it's got a number in a parentheses with it. What this letter does, the letter H, what that number is telling you, this number right here is telling you how far to the right or to the left you're moving the vertex, right? Because it's in here with the x, we're talking about on the x-axis, we're moving our vertex from the origin. We're going to move it to the right or we're going to move it to the left. Okay, and this sometimes even confuses me, so don't have a bad feeling about yourself if this is a little bit complicated. All right, so the part that always confuses me is whenever I see -2 in here, I'm like, oh, that probably means you go over 2 places to the left. That's what, I mean, that would make sense in my head. And if it said -3, that would mean, oh, don't you move it 3 to the left. And unfortunately, that's not the way that it works. It's actually the opposite of the way that it looks. And I think that's because this is a -h up here, right? So this is going to move you to the right or to the left. R or L. That's what that says, right or left. It's going to move you to the right or to the left. And it's always the opposite of the way that it looks in the question. So like this one is going to move 2 places to the right. So instead of having its vertex on the origin, this one is going to start right here, 2 places to the right. It's always the opposite because this is a negative sign up here, or a subtracting sign. It's always the opposite of the way that it looks. So this is actually going to be 2 to the right. Right? So the vertex of this one would be at 2, 0. The axis of symmetry would be like right here, right? This is going to be the middle of it. Axis of symmetry would be over at 2 on the x-axis. This one opens. How do you know if it opens up or it opens down? You look right here. This number is going to tell you whether it opens up or down. If this is a positive, it's going to open up. And then This number tells you if it's pretty wide or if it's pretty narrow. And when that number is less than 1, it's pretty wide, right? And so if I had to compare it to the original one, I would say this is wider. If I wanted to use the real math word, I would use vertical shrink by a factor of 1/2, right? By a 1/2 factor. So it may ask you to do some of these on our questions today. And so the big idea, and I'm going to really emphasize this on the next ones, this number in the parentheses, it's going to fool you. It's always the opposite of what it looks like. So if it's -2, that's moving it 2 to the right. If it was -5, that would move it 5 to the right. -3 would move it 3 to the right. -1 would move 1 to the right. And these down here that have plus signs, it's going to be going to the left. And so this is actually going to be 1 to the left. This is going to be 3 to the left. +5 would be 5 to the left. +2 would be 2 to the left. +10 would be 10 to the left. Because this has a minus sign up here, it's always the opposite of the way that it looks in the parentheses. And that's really hard for me to understand when I first learned it. And in fact, I'm still not the greatest at it. I'm sure there's a lot of people out there who are better than me. But that's my basic understanding of how these work. Okay, so we did number 1. Done. Now let's look at number 2. Okay, in the parentheses, I have -3. Now, -3, it's the opposite of the way that it looks to me, right? -3 is actually going to be 3 to the right. If I make my thing go here a little bit further, this is actually going to start right here. I say start, it's going to have a vertex right there, 3 to the right. Even though that's negative or minus, this is the opposite of the way that it looks. In the parentheses, it looks like -3, but when I graph it, it's actually +3, 3 to the right. So this is my vertex. The vertex is right here at the point 3, 0. This is also my line of symmetry that would cut my parabola right in half. That's at the spot 3 on the x-axis. That's why I put x equals 3. Does this open up or does this open down? Well, now I need to look over here. If this is a number that's a positive number, it's going to open up. And then what type of comparison is this going to be? Is this going to be wide? Is this going to be narrow? When this is a number bigger than 1, like obviously we have the number 2 right here. If it's a number bigger than 1, it's going to be pretty narrow. Now I'm freehanding this. On the next board, we'll actually learn how to graph it for real. But I'm just freehanding it just to kind of slowly ease our way into it. So this is a... Since this is more narrow, we don't call it a shrink like the last one. We call it a stretch because we've made it bigger than 1. And then we're going to say by a factor of 2. Right, so this is like twice as narrow, 2 times as narrow as the original ones. Okay. I believe they're going to give you some questions on the computer today where it's going to have you fill out these answers, you know, in little drop-down boxes. And so I just want us to practice some of these so that whenever you see them on the computer, you kind of have some experience and you aren't maybe as overwhelmed by all the choices that you have to fill out, because sometimes that can get kind of overwhelming when there's like 5 or 6 different little drop-down boxes that you have to do. Okay, there's number 2. Number 3. Let me go back to the beginning here. Number 3, the fact that it has +1 in here is a big clue. Now, my instincts would tell me +1, oh, that means you move it 1 place to the right. No, 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 no. So it's the opposite of the way that it looks. So instead of +1, I need to do -h or subtracting. I'm going to do the opposite way. +1 actually means you move 1 to the left right there. Now I'm going to fill in some other spots just for fun. But I'm actually, when it is +1, that's telling you to go to the left. Okay, 1 to the left right there. It's always the opposite of the way that it looks. So my vertex is right here at the point -1, 0. If I draw my little line of symmetry to kind of split it in half, that's going to be at the spot x equals -1. -1 on the x-axis is where I just drew that dotted line. Now, does this open up or down? I look right here in front of the parentheses at your letter A. Your letter A is going to tell you when the letter A is negative, that means it opens down. And this doesn't really have a number. That means it's an imaginary 1. When it's -1, it's the normal width. It's the normal width or narrowness. You haven't really changed how wide or narrow it is. But what you have done is this is a reflection, right? You flipped it down. This is a reflection over, we took it and we flipped it down. We went across this right here, which is the x-axis. we have flipped it, or we've done a reflection over the x-axis. Okay, so we moved it 1 to the left, and then we flipped it down. That's basically what we did on this one. Those were the two transformations. We did a slide 1 to the left, and then we flipped it, reflected it over the x-axis. Okay, we're 3 for 3. We have one more. Grand finale. Hopefully it's starting to make a little more sense. I apologize if I still had it sort of confusing there at the beginning. Okay, the very last one, right here. This is where my eyes are always drawn to first. Even though it's not the first thing in my list, I just like to do this part first. It says +3. It's the opposite of the way that it looks in the parentheses here. In the parentheses +3, I have to know that even though it looks like +3, and I would assume 3 to the right, that's actually wrong. +3 means go 3 to the left. And so I'm going to go way over here, 3 to the left. This is my vertex at the point -3, 0. That also means my axis of symmetry, if I use that to help me kind of split it in half, is going to be on the x-axis at -3. See how these are always the same, right? That has to be the case. And then how do I decide if it opens up or down? I go back to the original statement, and I look right here. This is the letter A right there. So you can see my A right there. Matches up with that. If it's a negative, that means it opens down, and that's the case right here. And then this is a fraction, right? This is a fraction. It's an amount between 0 and 1, -1. When it's an amount between 0 and 1, or 0 and -1, that means it is more wide open, right? This is pretty wide, much wider than the last one that I did. So how have I flipped this thing? Let's see. The first thing I did is I did a reflection because I flipped it down. Reflection over the x-axis. We did a reflection over the x-axis, and then it's also been made wider, right? We've widened this thing out. That's called a vertical shrink. When you make it wider, you call it a shrink. When you make it more narrow, you call it a stretch. Vertical shrink by a factor of 2/5. Notice I didn't put negative on it. I looked that up the other day in my video. I wasn't sure. Let me move my board there. A vertical shrink by a factor of 2/5. That is just kind of the fancy way of saying, hey, I made it wider than the original one. Okay, so on our questions today on the computer, if you get stuck on these, you've got all those drop-down boxes, and you're having a hard time, come back to this point in the video or have this part of the video paused and just kind of use my my questions here as a guide so that you can answer those drop-down questions in our assignment. All right, let's go to our next board. Let's actually try to graph one. All right, here it is. Now, how do you actually graph one, right? So I just filled out all those questions about the characteristics of a graph. Now, how do I actually graph it if they ask me to do that? Because at some point, you'll probably be asked to do that. All right, let's see. What I want to do first is I probably want to do some of those questions that we just answered on the last board. I kind of want to just kind of have that in my head, right? These things right here on the right-hand side. If I can just kind of, in my head, have a game plan of what this should look like, that might help me. So my eyes are automatically drawn here. This is where I always go first. I always go to the letter H, just my opinion. That's the easiest for me. When it says -2, I know that means it's actually 2 to the right. It looks like you would think -2 would be 2 to the left because it's negative, but it's not. It's always the opposite of the way that it looks in the parentheses. So this is actually going to be 2 to the right. I'm going to go ahead and put my vertex right there, right? So I have my vertex. My vertex is at the point 2, 0. I also have my axis of symmetry. If I wanted to draw it to kind of help me, I'm just going to draw it a little bit. I don't need to draw it all the way to the top and the bottom of my page. My axis of symmetry is right here at the point, or not the point, the line, x equals 2. Excuse me. And now, in the previous board, I would just look at this and I would say, okay, it's positive. That means it opens up. And then I would just kind of freehand it, right? I just freehanded the fact that this is 1/2, the fact that this is my letter A, the fact that my letter A is less than 1 tells me this is going to be pretty wide. It's going to be wider than the original one. So I know this is going to be a vertical shrink. This is going to be pretty wide. But I just can't freehand it, right? Freehanding it isn't going to work on a real question where you actually have to graph it. 1/2 factor by a factor of 1/2, right? I just can't freehand this. That's not going to work on a real math question. So what do you do when you actually have to put the real dots? You just can't freehand it. Okay, it's not too bad. What you do is you go back to the basics. Anytime you're stuck on a graph that you don't know how to do it, do one of these little x and y tables, right? Pick some numbers that you want to put in the spot of the x and then graph them. Now, the fact that we already know the vertex and we already know the axis of symmetry gives us a great help. Instead of just picking random numbers, let's pick numbers that are close to the vertex. Right? Don't pick 2 because we already have the dot for 2, but how about I pick 1? And then how about I pick 0? I'm just going to pick, well, let's just pick 1, and I'll show you how that can be used, and then in a minute we'll pick 0. Right? If I pick 1, since it's only one spot away, I like to pick the numbers that are right next to the vertex because then it's going to give you the nice curve and it's going to be really easy to graph. So I'm going to pick the number 1. I could have picked 3, but to be honest, 1 and 3 are just going to be reflections of each other. So as long as I know one of these answers, I can just reflect it and get the other answer. So I'm going to pick 1 just because 1 is a little bit easier than 3. If I put 1 right up here in the spot of the x, it would say 1/2 times 1 minus 2 squared, right? All I did is substitute 1 in the spot of the x. 1 minus 2 is -1. And now be careful. This is where you're going to mess up. If you're going to make a mistake, it's going to be right here. -1 squared. Do the exponents first. Do not do the multiplying first. -1 squared is -1 times -1. That is 1. 1 times 1/2 is 1/2. And so the point 1, 1/2 should be on my graph. 1, 1/2. So at 1, I should be only 1/2. 1 to the right, half of the way up. I didn't even make it all the way up here to 1 yet. Now, because this is an axis of symmetry, I can just do the reflection, right? This is one spot to the left of my axis of symmetry. So now I can go one spot to the right of my axis of symmetry. Let me get it back on there. I kind of scribbled it. So one spot to the left and one spot to the right should have the same value right there. So now I have 3 points already. Let me go ahead and do another one just because I really can't see the curve very well. What about if I put 0 in the spot of the x up here? Right? If I put 0 in the spot of the x, here's what my equation would look like. It would look like 1/2 times 0 minus 2 squared. Okay, we all know 0 minus 2. That's -2. -2 squared is next. -2 squared, -2 times -2, that's 4. And so I have 4 times 1/2. What's half of 4? Half of 4 is 2. And so the point 0, 2 is on my graph. 0, 2. 0, 2, right here. Now, since this is 2 spots to the left, see how here's my axis of symmetry, and this dot is 2 units to the left? I can go 2 units to the right, and it's going to be the same exact height. Those are the same height, here and here, 2 spots to the left and 2 spots to the right, and now we can start to see this curve forming. And you can see how this is a little bit wider than the normal ones, right? And so that's how you actually want to graph it. You want to first find the vertex, find the axis of symmetry by looking right here, and then once you know that amount, then you can make your little chart and pick numbers that are close to that vertex, right? If your vertex is at 5, then I would pick 4 and 6, right? And there were 3 and 7. If your vertex is over here at -3, then I would pick, or -3, sorry, it's right there. Then when I made my table, I would pick numbers that are close to -3, like I might pick -2 and -1, right? So pick numbers that are close to your vertex, and that's going to make your table, that's going to make your chart so much easier. It's going to make your graph so much more simple to make. Let me see. I've got more boards, but you know what? I feel like this is a good place to stop. I'll break this lesson up into 2 days because I'm almost at 25 minutes now, and I don't want this to drag on to too long. So what I'm going to do is I'm going to pause right here, and this will be it for today. I will give you some questions on the Big Ideas Math site. The people who've been keeping up with them and have been doing the assignments the day or the day after that I post the videos and post the questions have been doing an awesome job. I appreciate everyone for doing that. Use these videos to help you, and I will be back on Monday, and we'll finish this lesson with the second part of 8.4 on Monday. Thank you so much, and have a good day.